We're at the spectrophotometer now. This is a Spectronic 20D digital, and it measures the absorbance of light. Christy can be explaining how this works a little bit better. But here is where we're going to measure how much light the bacteria will absorb, and it's proportional to the concentration or the amount of bacteria. Okay, so if you have twice as much bacteria, it will absorb twice as much light. Okay. All right, so when we first get this on, it needs to be on 15 minutes before we start measuring. And so this has been on for 15 minutes or more. And then the first thing we want to do is this button up here. It's called the wavelength. And so this wheel or button will spin, and if you look over here, it changes that. And so this is the wavelength of light. And the literature tells us that 600 nanometers is a good one. And so this is the 600 billionths of a meter long, as the light moves in a wave pattern. But 600 nanometers is a good one to choose for measuring absorbance in bacteria, especially E. coli. Okay. And you will have to repeat this experiment, the whole experiment, for every different type of bacteria. So this is only going to work for E. coli, what we're doing today. All right, so we set the wavelength, and now we have nothing in here. There's no tubes in here. We set it on transmittance, so this mode button here changes from transmittance to absorbance to concentration to a multiplication factor. So we're going to work with mostly the transmittance and the absorbance. So transmittance, and then we go to this 0% T. We set it to 0, so it was already preset pretty well. Okay, so that's set to 0, and it'll drift a little bit. That's okay, a little bit. And then we're going to take a blank, and a blank is just the media that the bacteria is in this case saline. We put it in saline, and in the test tube. And so this blank, and we wipe off the test tube with some Kim wipes, and then we flip it up and put this in here. Now this lid won't close, so we've made a makeshift lid. Okay, and this is now we got to set the 100% T. So we set 100% on the transmittance. So this knob is 100% T. So we get it down to, and I'm not sure if you're seeing this. You might be seeing this. Probably not, but I'll show you when we're done. So we get this to right about 100. Okay, so that was at 100 when we had the covering over it. Okay. All right, so then that can come out, and then all we have to do is switch to the mode to absorbance. So it's very important we do that, because transmittance is the amount of light that comes through the bacteria. We want to know the amount of light that the bacteria absorb. Okay. All right, so now we can take our samples, and we're going to start with the 1X, and we wipe it off. And if you don't have the vortexer handy, you just flick this. Take your finger and flick it, hold it firmly up here by the neck, and flick it, and it'll cause a vortex or a little hurricane or a tornado in there a little bit. And mix everything up, and then we'll stick it in here, and put the cap on, and then we write down that this one says we have absorbance of 1.13. Okay, and then we take this one out, set it aside, get the next one in line, it's a half X. Make sure you do this in the right sequence. Put the lid on, and this one says we're at 0.758. And then this next one is 1/4. And we're at 440. 0.440. Actually, 0.440 is fine. And you don't want to wait very long, because as you wait, the bacteria start to settle, and then that'll increase the amount. Okay. And then this is the 1/8. And it's a 0.233. And then we're going to do 1/16. And it's a 1.122. And then the final one, 1/32. And we're at a 0.065. Okay, and then we're done. And this part of the experiment is concluded, and what we need to do now will be putting this on a graph, and the graph will look something like this. Absorbance on the left hand x column, and then on the bottom would be the 1x, the 1/2 x, the 1/4 x, 1/8 x. And then we just plot the numbers. So, 1x is going to be higher up here, and then maybe the next one down here, and we get a line here, and then we're going to draw the best fit line through there. And so this would be like absorbance of 1, 0.0, 0.5. Okay, so what I'm saying when you're not seeing this is 1.0 up here, 1.5 here, and 0.25. So we'd have this laid out in a nice linear fashion. Here's the absorbance, that's the absorbances, and then this is the dilution factor, and then we plot the points, and then we draw a best fit straight line. We don't go dot to dot, we'll do a best fit straight line. And then that gives us something to compare, an unknown sample. So if we have an unknown and we want to figure out what it is, we just record the absorbance, come across and hit the line. It came across, hit the line, and then came down, and so it's pretty similar to the 1/2 dilution. Okay, but right now we don't know what the 1/2 dilution is as far as cells. And so we want to figure out the cells, and so to do that we have to do plate count, so we have to grow them up on plates. So we're going to do the other dilution, zero dilution, and put them on Petri plates, agar plates, and then grow them up overnight, and then we'll do some counting of that. And then from there on, once we get that's all correlated, then we don't have to do any of this. We don't have to do any dilutions, we don't have to do any plating. We just record the absorbance of our sample, and then we go to this graph that we have already created and plot it out and figure out how many cells that were in that sample. All right, so now we'll end here, and then we'll go back and set up for the zero dilutions for the plating, the spread plate.